Welcome back to the long jump event at the 2022 Winter Olympics in Beijing, China. I'm your host, Justin Doyle. As you can see, the last contestant of the event, Rose Hansen, prepares herself for takeoff down the ramp. Today we're going to show you the applied physics to see if she has what it takes to make it 0.6 meters and take home the gold. Hey, welcome back. We're down here with the crowd, and we're also with Rose Hansen, who's taking a break from the ramp. She's represented as this little blue ball. Okay, so to get started, let's talk about what a projectile is. According to biomechanical basis of human motion, projectile motion is any object that has no external forces acting on it except for gravity and air resistance. So when Rose leaves the ramp, she will be considered a projectile, and that's what we're going to refer to her as. I like to think of a projectile as anything that's headed up due to initial velocity, and that is eventually overcome by the force of gravity. So let's find out how far Rose is going to go. So we must first find her potential energy, and that equals mass times gravity times height. We know her mass equals 0.00105 kilograms. Acceleration due to gravity is 9.81 meters per second squared, and the height of the ramp equals 0.6 meters. So we need to multiply these together because of the equation. So doing so gives us 0.00618 joules. So we know that potential energy is equal to kinetic energy, and that kinetic energy equals half times the mass times the velocity squared. And so we can go 0.00618 joules equals half mass velocity squared. We know the half of the mass equals 0.0005, so we can divide this by 0.0005 kilograms, and that gives us 12.36 meters squared a second squared equals velocity squared. So we're going to want to take the square root of both sides, and that gives us 3.516 meters a second, and that is the initial velocity at 30 degrees. Okay, so now we're going to want to find the y component. In order to do so, we need to multiply 3.516 by the sine of 30 degrees, and that's going to give us 1.758 meters per second. Okay, so now we need to find the time that she's in the air. In order to do so, we are going to use the kinematic equation for time. And that is y final equals y0, or y initial plus y initial, the y component, t, minus half gravity t squared. Okay, so we know y final is 0 meters, so then we also know that 0.445 meters is the height from takeoff to landing, plus 1.758 t minus half 9.81 meters a second squared. That's also meters a second. T squared. Using the quadratic formula in our calculator, we can get 0.277 seconds. So now the velocity in the x direction. So to get that, we can go 3.518 meters a second times the cosine of 30 multiplied by the time right here, and that's 0.277 seconds. And that gives us 0.675 meters. So let's see if that's going to win the gold. Does Hansen have what it takes to win the gold? Here she goes as she descends down the ramp. Hansen has won the Olympic gold medal. Little after video here. I just wanted to show you how I made this project. So the landing zone is right each line is 0.1 meters. I did a 30-degree angle with 3/4 inch tubing, and that's a 30-degree angle, which is pretty standard for an Olympic ramp. I did 90 degrees for the ramp, just to reduce friction as a variable. And I used 1x6s, and a little bit of artwork on there, and the Olympic symbol. Thanks for watching.